So today we're going to go off of what we worked on in the last video, and so it's just kind of an intro to Hicksian demands. So here it's going to be a little bit different, but I will be using the same problem. So if you want to go back and just learn about indirect functions, I would suggest that you go to that video, the very last video that I made. So here I'm going to kind of take it to the next level and introduce Hicksian demands. So to start off, we're kind of switching the ball. We're kind of switching our objectives and our constraints, and we're focusing on the consumer's expenditure minimization problem, right? So let's kind of break these four words apart. A consumer's, like the consumer's expenditure is the things that consumers buy, the amount of money that a consumer is spending. So that's consumer's expenditure. Minimization means that you're trying to minimize the amount of money that you're spending, right? You don't want to spend $1,000 on something that costs, 10, right? You want to minimize the amount of money that you're spending. That's just, this is just basic consumer behavior. And then a problem, right? We're going to start off with some problems. The whole concept here is, given a constraint that I have in my utility, in my well-being, right, in my level of well-being, how can I attain that same level of well-being in the cheapest way possible, right? Our cheapest way possible is this objective. This is our goal. I want to spend as few dollars as I can, given that I am, benefiting myself the same way that I should, the constraint that I have, right? So our constraint minimization problem would be, okay, min of x comma y, right? The consumer chooses x and y. Given that, this is my goal, here's my goal, such that we are fixing that constraint, right? Subject to the goal of hitting some kind of utility level, right? So again, one thing you should notice that, hey, these are flipped from the maximum utility problem, right? The max that we were working on, it is flipped. So make sure you do it when you have these types of problems in the exam. Make sure that you know what my goal and my constraint is, my objective and my constraint. So make sure you know that, right? So here, I'm not going to go through the first two problems because, like I said, I did work on this in the last example. Here, we're just looking for our optimal bundle, and we're plugging it back in to find the indirect utility, right? We have 4 and 4. Go back in, plug it back into the objective, and you get 4 times 4 is 16, and that's my indirect utility. I don't want to go over it too much because I worked on it in the last problem. Let's work on number 3, right? It's kind of going off of what we had. Right? Now we want to know, how can we get the cheapest bundle that gives the same level of utility of that 16, right? Here we really care about the number, right? Here we really care about that utility number. So what I did here was, okay, I want to minimize my expenditure. Here's my expenditure, such that this is my constraint. I did the same, right? I do my Lagrangian. I take the partial derivative with respect to x1, partial derivative with respect to x2, and then partial derivative with lambda, right? And I get, when you take all the derivatives, cancel that lambda out, you get this, right? You end up getting these two. And then what you can do is set that fraction, right? You get 1 over x is equal to lambda, and you get 1 over x2 is equal to lambda, and then you get 1 over x1 is equal to lambda. Oh wait, the lambdas are equal to each other. Why not equal them together, right? It's just basic algebra. And then you do cross multiplication, and you get x1 is equal to x2, okay? Oh, that's really helpful, right? If they're both equal, I have to plug it back into something. Now that something is very important, right? Where do I plug it back into, right? What you will do here is you're going to be plugging this back into your utility function. Now, you're probably asking, why my utility function? Don't we always plug it back into our budget constraint? No, right? This is a minimization problem. This is an expenditure minimization problem. We plug this back into our constraint, right? because we have a value given for that 16 given, it's very, very easy to just plug it back into our constraint, because that is what we're constrained by. That 16 is what we're constrained by. Those bundles, the x1 and x2, are dependent on that 16. So sorry, I made a typo right here. This should be, oh no, sorry, this is right. So you plug this back in, right? So it's going to be x1 multiplied by x1, because again, x1 is equal to x1. x1 is equal to x2. So you can just do that, and you get x1 squared is equal to 16, and you end up getting square root of 16 is 4 and 4. And you get our Hicksian demand. So this is our Hicksian demand. Okay? This is our Hicksian demand. And what we do now is, remember, to find our, to go back and find our income, we just plug this back into our budget constraint. Or, sorry, our budget, like our expenditure problem, right? So plug this back into our objective, and we get 4 times 1 plus 4 times 1. Now you're probably asking, where does that 1 come from? Remember, don't forget, our prices are 1, right? And you get 4 plus 4 is equal to 8, right? To check your work, you can see right here, oh my god, my income was 8. And you'll see that, you know, they should kind of match up when we're working with like actual numbers. They should match up. So here we see that, okay, a quick way to do that, if you don't care about the Lagrangian, which you should, it's a good way to check your work. You can just see, okay, our P1 over P2, we know that both of the prices are 1 to just become 1, right? X1 over X2 is equal to 1, and you do cross multiplication and you get X1 is equal to X2. So moving on to a new problem, I actually really like this problem. It's a good way to kind of work on an easy minimizing expenditure problem. So what is the cheapest way to attain the utility of 120 for a consumer with the following preferences, right? So we're given our utility function and our budget constraint, and whenever you see this, you should pretty much know that, oh, okay, this is a perfect substitution. Okay, now I'm going to work with those 3 graphs, right? All x, all y, or interior solution. So these should probably pop up in your head. And now you're going to look through, okay, so what is the cheapest way? Whenever you see that, like, oh, what is the cheapest way to attain this fixed utility, you're going to have to think of consumer expenditure minimization problem, okay? So we are given this, right? Now they're going to say, okay, write the constraint problem, the constraint minimization problem, and our objective, again, is going to be our income, right? We want to obtain a cheapest way, and our constraint is that utility that's given, right? And so this is what it would look like. This should be your answer for that. If they ask you for a constraint minimization, like just an equation, an expression to write that out. So what you would do here is that, okay, there are 3 ways to hit this certain utility, right? Equal to 120. What we would do is basically just equate this, make this equal to 120, right? And you can either have all x, all y, or some combination of 1 and 2, right? So what I did here was, if I had all x, I would basically just ignore my x2, right? If I had all x1, I would just ignore my x2, and I would get 6x1 is equal to 120, right? And that's where I got the 20 units of good 1 from, right? So it's just 120 divided by 6. Okay, I just ignored my all y because we're looking at all x. Here, opposite, we're going to do all y, so we're going to ignore our x1. Here again, sorry if I'm mistaking with the expression, it's x1 is x and then x2 is y. So yeah, if we're ignoring that x1, we're just looking at our 10x2 is equal to 120. That's where we're getting that 12 from, because it's just 120 divided by 10. Okay, and that's my all y. And we know that, and then combination of combination of 1 and 2, it would just be our, that would happen only if our MRS is equal to the price ratio. Remember, right? Whenever our MRS is equal to px over py, in this case x1 over x2, it's not equal, right? This is 6 over 10 and 2 over 5, right? 3/5 is not the same thing as 2/5. So we know that, okay, so now what we're going to do is that, okay, we have a 20 and we have a 12, right? We have 20 and we have 12. All I'm going to do is plug those numbers back into my budget constraint, right? We want to plug it back into our constraint, just like we did over here. Plug it back into my constraint and check out that income. Check out what gives me the lowest, or what gives me the lowest expenditure, right? Lowest amount of money spent. When I do 20 and you plug it back into all of my X1, I get 20 times the 2, right? 2 times 20, and I get $40. Here, I have 5 times 12, right? Because that's my X2, and that's 60. Wait, I would much rather, if I'm obtaining the same utility, I would much rather only spend $40 instead of 60, right? Much rather do that, and that is why I choose that $40, right? I would be using, right, that's my expenditure function. Expenditure function is basically, okay, I'm just plugging this back in. It's 2 times 20 plus 5 times 0, because, again, we're not spending any money on X2. It's just $40, okay? And now I know that, okay, what is the cheapest way? I would just be purchasing X1. Our goal is to minimize our costs. That is the goal in this problem, right? And so a quick way to do this is really, you can just check out the coefficients, right? Look at the MRS, look at the price ratio, and you see that 3/5 is greater than 2/5. Okay, picture it, right? Picture the 3 graphs that I showed in my previous video about perfect substitution. Picture it, right? Our MRS is higher than the budget constraint, right? If it's steeper than the budget constraint, then we're going to be hitting all X at the end of it. So it's going to be an all X solution. Then I'm only going to look at my X's and not look at my X2. So I'm only going to look at my X1. And it's going to be 6X1 is equal to 120. Okay, now I know that X1 is 20. 20 times, plug it back into my budget constraint, is $40. Perfect, done. I know that $40 is the best way for me to attain that utility of 120. So, thank you.